Black holes have long captivated the human imagination, representing the ultimate frontier of our understanding of the universe. Often portrayed as voracious monsters devouring everything in their path, these cosmic phenomena are far more nuanced and fascinating than popular media suggests. At their core, black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape. This definition, rooted in Albert Einstein's general theory of relativity, paints a picture of an invisible boundary known as the event horizon, beyond which the laws of physics as we know them break down. One of the strongest aspects of discussions on black holes is how they bridge theoretical physics with observable reality. For instance, black holes form when massive stars exhaust their nuclear fuel and collapse under their own gravity. Stellar mass black holes, with masses about 10 times that of our Sun, are the most common, emerging from the remnants of these stellar explosions. Intermediate black holes, ranging from thousands to 1 million solar masses, remain a topic of ongoing research, with debates about their formation, possibly through mergers of smaller black holes or direct collapse in dense star clusters. Then there are supermassive black holes, lurking at the centers of galaxies, including our own Milky Way's Sagittarius A star, which boasts a mass of about 4.3 million suns. These giants likely grew through accretion of gas and dust, or mergers during galactic collisions. What makes black holes so intellectually rewarding is their role in testing the limits of physics. The script excellently illustrates this through analogies, such as compressing the sun into a sphere just 6 kilometers across, transforming it into a black hole. This highlights a key point. Black holes aren't objects in the traditional sense, but warped space-time regions. Their blackness stems from absorbing all radiation and matter crossing the event horizon, behaving like perfect black bodies in thermodynamics. Detection relies on indirect evidence, like the accretion disks, where infalling matter heats up to plasma states, emitting intense X-rays and making the surroundings some of the brightest objects in the cosmos. Binary systems, where a black hole orbits a companion star, allow astronomers to infer mass and distance from orbital perturbations, a method that has confirmed dozens of black holes. Historically, the journey to understanding black holes is a triumph of human ingenuity. The concept dates back to the 18th century, with John Michel and Pierre-Simon Laplace proposing dark stars from which light couldn't escape. Einstein's 1915 theory revitalized the idea, leading to Karl Schwarzschild's solution describing the Schwarzschild radius, the critical size for black hole formation. The term black hole itself, coined by John Wheeler in 1967, popularized the concept. Stephen Hawking's 1974 breakthrough on Hawking radiation suggested black holes aren't eternal. They evaporate over time, linking quantum mechanics and gravity in ways that challenge our paradigms. Yet, even in these fundamentals, controversies lurk. The script's portrayal of black holes as terrifying can sensationalize them, potentially misleading lay audiences into viewing them as threats rather than natural phenomena. In reality, The nearest black hole is over 1,000 light-years away, posing no danger to Earth. Moreover, the simplification of formation processes overlooks debates such as whether primordial black holes from the Big Bang exist or if intermediate ones are as rare as evidence suggests. These points underscore the script's strength in accessibility, but highlight where deeper nuance could prevent misconceptions. Visually and narratively, black holes inspire awe. The first image of a black hole, captured in 2019 by the Event Horizon Telescope collaboration, depicted the shadow of M87's supermassive black hole, a glowing ring of hot gas against a dark void. This wasn't a direct photo, but a reconstruction from radio waves, emphasizing how technology pushes boundaries. The script's emphasis on this milestone is spot on, reminding us that black holes transitioned from theory to observation, validating Einstein's predictions. In essence, the fundamentals of black holes reveal a universe governed by elegant yet extreme physics. They challenge us to rethink space, time, and matter, offering profound insights into cosmic evolution. As we delve deeper, these enigmas not only expand our knowledge, but also fuel philosophical questions about existence itself. Venturing beyond the basics, black holes invite us into realms of speculation that blend cutting-edge physics with philosophical wonder. One of the script's standout strengths is its ability to weave in these mind-bending ideas without overwhelming the audience, using relatable analogies and pop culture references to make abstract concepts tangible. For example, the phenomenon of spaghettification, where tidal forces stretch an object like pasta as it approaches the event horizon, is explained vividly, evoking both horror and fascination. This not only highlights the terrifying power of gravity, but also underscores black holes' role as natural laboratories for extreme physics. The script excels here by grounding such descriptions in real science. The uneven gravitational pull, stronger at the feet than the head for a falling astronaut, leading to molecular disintegration. It's a perfect illustration of how black holes challenge our intuitions about space and time. Central to this speculative allure is the curvature of space-time, a concept Einstein introduced that the script demystifies through everyday examples like Earth's orbits. Satellites like the ISS aren't flying, but falling in a curved path, mirroring how objects near black holes get trapped in inescapable trajectories. This builds to the inescapable conclusion: once within a black hole's grasp, escape velocity exceeds the speed of light, rendering survival impossible. The script's narrative flow shines in portraying this as a thrilling, cosmic adventure gone wrong, emphasizing the futility of fuel or technology against such forces. It's educational, yet engaging, prompting viewers to ponder humanity's limits in the universe. However, this is where controversies emerge. The script's exploration of time dilation, time slowing near a black hole due to intense gravity, is accurate, but ventures into debatable territory when linking it to time travel. Drawing from Interstellar, it suggests Orbiting a black hole could propel someone into the future, with 1 year equaling 80 on Earth. While rooted in relativity, clocks tick slower in stronger fields. The practicality is contentious. No spacecraft could withstand the radiation or tidal forces, and escaping the gravitational well remains theoretically implausible without exotic matter or wormholes. Critics argue this blurs science with sci-fi, potentially misleading audiences into believing time travel is feasible soon. Moreover, backward time travel via closed time-like curves, loops in spacetime allowing revisits to the past, raises paradoxes like the grandfather paradox, where altering history could erase one's existence. The script acknowledges the need to exceed light speed, impossible per relativity, but downplays ongoing debates in quantum gravity theories, such as whether these curves even exist. Another highlight is the discussion of the singularity at a black hole's core, a point of infinite density where physics breaks down. This is where the script's educational value peaks, noting the need for a quantum gravity theory to reconcile general relativity with quantum mechanics. It's a nod to unresolved mysteries, inspiring curiosity about the universe's fundamental rules. Yet this segues into highly speculative ideas, like the universe itself being inside a black hole. The script posits the Big Bang singularity, mirroring a black hole's, suggesting our expanding cosmos could be the interior of one in a larger multiverse. This draws from theories like those of Nikodem Poplavsky or Lee Smolin's cosmological natural selection, where black holes birth new universes. It's intellectually stimulating, explaining dark energy as infalling matter from an outer universe accelerating our expansion. The analogy to a tree branching into multiverses is poetic and accessible, one of the script's best creative touches. But here's a major point of contention. These ideas lack empirical evidence and border on pseudoscience if presented without caveats. Mainstream cosmologists debate the multiverse, with some viewing it as untestable philosophy rather than science. The script mentions TON 618, the largest known black hole with an event horizon spanning 390 billion kilometers, to argue scale, but dismisses it as too small for a universe, ignoring that in higher dimensions or modified gravity, such constraints might not apply. Furthermore, implying we can't reach the universe's edge due to donut-like topology is speculative. Our observable universe is flat, but global shape remains unknown. This anthropocentric framing that black holes hide secrets or are monsters can sensationalize, drawing criticism for prioritizing drama over objectivity. The script's reference to five-dimensional spaces from Interstellar, advised by Kip Thorne, is another gem. It introduces holography, where black holes might encode information on their surfaces like a 3D image on a 2D film, resolving the information paradox. Does data vanish or evaporate with Hawking radiation? This ties into string theory and the ADS-CFT correspondence, showcasing black holes' potential to unlock quantum gravity. Yet, controversy arises in suggesting we might already live in a black hole simulation, echoing simulation hypotheses without addressing falsifiability. Such claims, while thought-provoking, risk eroding trust if not balanced with skepticism. Overall, these speculative frontiers make black holes a gateway to profound questions about reality, time, and existence. The script's blend of wonder and warning is its triumph, but the lack of counterarguments to fringe theories invites debate, reminding us science thrives on scrutiny. As we conclude our exploration of black holes, it's essential to address the challenges and controversies that define this field, while looking ahead to what the future might hold. The script's greatest strength lies in its ability to spark debate and curiosity, transforming a scientific topic into a philosophical discourse. By questioning whether decoding black holes could usher in a new era of science, it invites readers to engage actively, pondering the implications for humanity's place in the cosmos. This reflective ending is masterful, encouraging subscriptions and likes without feeling forced, and it encapsulates the wonder that makes black hole studies so compelling. Yet, it's precisely in these provocative elements that the most heated controversies arise, revealing the tensions between established knowledge and bold speculation. One of the script's highlights is its historical narrative, tracing black holes from 18th century musings to modern observations. This timeline underscores human progress, with milestones like the EHT's 2019 image of M87 star serving as a pinnacle. The script aptly explains why the photo, a fuzzy orange ring rather than a dramatic vortex, disappoints Hollywood expectations. It's the black hole's shadow, cast by surrounding plasma, not the hole itself. This demystification is educational gold, clarifying that colors represent intensity, not reality, and that M87 star was chosen for its massive size, 6.5 billion solar masses, and relative proximity, 55 million light-years. Such details ground the discussion, highlighting how international collaborations advance science. The emphasis on indirect detection via X-ray emissions or gravitational waves from mergers detected by LIGO shows black holes as dynamic players in cosmic evolution, influencing galaxy formation and starbirths. However, controversies abound in how the script handles scientific accuracy and sensationalism. A prime example is the portrayal of black holes as inescapable voids, ignoring Hawking radiation's theoretical evaporation. While minuscule for stellar black holes, taking longer than the universe's age, this omission could mislead, as it challenges the eternal monster image. Critics might argue this perpetuates myths, especially when the script anthropomorphizes black holes as monsters. This sensationalism, while engaging, risks alienating purists who prefer objective language. Moreover, factual tweaks are needed. The Big Bang is about 13.8 billion years old, not 13.7, and the Sun's Schwarzschild radius is roughly 3 kilometers, not 6. Minor slips that underscore the need for precision in popular science. Deeper debates center on unresolved paradoxes, which the script touches but doesn't fully unpack. The information paradox, whether data falling into a black hole is lost forever or preserved in Hawking radiation, remains a battleground. Hawking initially bet against preservation, but conceded in 2004. Yet solutions like firewalls, hypothetical energy barriers at the event horizon, divide physicists. The Scripps holographic idea, where black holes encode information on their surfaces, is intriguing but controversial. It's inspired by the ADS-CFT correspondence in string theory, unproven in our universe. Presenting it alongside Interstellar's five-dimensional tesseract blurs lines, potentially confusing viewers about what's theoretical versus fictional. Similarly, multiverse claims that black holes spawn universes stem from speculative models like eternal inflation, but lack testable predictions, drawing ire from empiricists who decry them as unfalsifiable. Looking forward, the script optimistically envisions a future where black holes' secrets are unlocked, a vision shared by ongoing missions. The James Webb Space Telescope is probing early supermassive black holes, challenging formation theories by revealing them in the universe's infancy. Upcoming gravitational wave detectors like LISA could map mergers across cosmic history, testing general relativity in extreme regimes. Quantum computing might simulate singularities, bridging the relativity-quantum divide. Yet, ethical and philosophical controversies loom. If black holes enable time travel or multiverses, do they imply determinism or free will? And in an era of misinformation, how do we balance excitement with rigor? The script's call for research investment is spot on, as understanding black holes could revolutionize energy via analogs like acoustic black holes or computing inspired by holography. In wrapping up, black holes embody the universe's duality, awe-inspiring wonders that humble us, yet contentious enigmas demanding scrutiny. The script's blend of facts, speculation, and provocation is its triumph, making complex science accessible and debate-worthy. As we stand on the brink of new discoveries, one thing is clear: black holes aren't just cosmic curiosities, they're keys to unlocking reality's deepest truths. Whether they reveal multiverses, time machines, or merely more questions, their study promises to redefine our cosmic narrative.